Welcome all. I am Rupali Kawade, working as an assistant professor in the Department of I2C Engineering of J.H. Raison Institute of Engineering and Technology, Bagul, Pune. Today I am going to discuss about the topic I2C, that is the Inter-Integrated Circuit Bus, which is a serial protocol used in the communication systems. This I2C, it is initially developed in 1980s by the Philips for the TV sets. It has a different speeds that comes under slow, fast and high speed. Slow speed means it is considered under 100 kbps. Fast, that is up to 400 kbps, and the high speed I2C, which can be recognized as a V.2.0, which has speeds up to 3.4 Mbps. The range of the communication in the I2C, it is limited to about 10 feet for the moderate speeds. It is used as a control interface to signal processing devices that have separate data interfaces. For example, RF tuners, video decoders, and encoders, and audio processors. Again, it also has a built-in collision detection mechanism. The addressing used, it is of a maximum of 10 bits. So it also supports the multi-master and multi-master with a slave function. It has a data broadcast general call function. Since only 2 wires are required in the I2C, it is well suited for the boards with many devices connected on the bus. This helps to reduce the cost and complexity of the circuits as additional devices are added to the systems. This is the basic I2C configuration, which has only 2 data lines, that is the serial data and the serial clock. Only 2 wires are used in the I2C communication. These two wires are always pulled up with the help of the pull-up resistors. The devices which are compatible with the I2C signals, that is SDA and SCL, are connected on the 2 pair of wires. The example shown, there can be 1 master or there can be 2 master and the multiple slaves. This is the basic configuration of the I2C. Then this is the I2C protocol, how the data is transmitted from master to the slave or slave to the master, or how the handshaking is done between the master and slave. What is happened initially, that is the start bit. Master, and it is always initiated by the master. Master will send a start bit. After the start bit, it will send a 7-bit slave address. After the slave address, that slave address is also issued by the master. After the slave address, the master will issue read or write bit. Now, based on the master is transmitter or master is receiving receiver, that bit will be either 0 or 1. Then the slave corresponding to the given address will acknowledge the address, and again based on the read-write bit, either master or slave will start the transmission. For each transmitted byte, there will be the acknowledgement for the receiver, and at the last after the final byte, always the master will stop the transmission. See this step by step. Initially, master sends start condition S and it controls the clock signal. Second step, that master always sends a unique 7-bit slave device address. After that, master sends read or write bit. If master sends 0, means slave will receive and or master will transmit the data. If that bit is 1, means slave will transmit or master will receive. Now the slave with matching 7-bit address always sends the acknowledgement bit AC. Then transmitter, it can be either slave or a master based on the condition given in the step number 3. Transmits the 1 byte of data. After this, the receiver issues an acknowledgement bit for the byte received. In this way, repeat the step 5 and 6 if more bytes need to be transmitted by a transmitter. Master always sends the stop condition P. For write transaction means the master is transmitting. Master issues the stop condition P after last byte of a data. As well as for read transaction, that is master is in a receiving mode. Master does not acknowledge the final byte. It will just issue the stop condition P to tell the slave the transmission is done. Thank you.